In this video we'll be looking at the command injection challenges on DVWA. We have the security level set to low initially, you can set that here, and we're going to take a look at the first challenge. So we have a form field here saying enter an IP address for us to ping a device. So let's try and put in just our local IP address. Submit that. And you can see it attempts 4 pings and then it comes back with the statistics, say 0% were lost. Let's actually open up Wireshark and we'll monitor any traffic here. Okay. I guess I don't have my group set up properly here, that's fine. Just had to run that with sudo. Let's go back and let's ping this again. And if we go back to our Wireshark, let's stop the packet capture, and you can see here we have our ping request and ping replies. Let's quit that. That's just for demonstration purposes, not really of any importance at all. So the pings occurred, and essentially what's happening there is this command is being run. Ping 127.0.0.1. Probably actually because it sent 4 pings, it's ping C4, and you can see that this is what we're getting. This is the exact output, the same as we would get on our command line. So what's the vulnerability here? Well, let's take a look at some of the links. Here's the OWASP link to command injection, and as it says, the objective is to execute arbitrary commands on a host operating system via a vulnerable application. Command injection attacks are possible when an application passes unsafe user-supplied data from forms, cookies, headers, etc. to a system shell. And that's exactly what's happening here. What we're supplying, the user input, is being sent to the backend to run on the shell using this command. So what could we insert here in order to inject something else? Let's think about the command line. So in the command line, potentially we could say we want to ping this, and then we put a semicolon and then ls. And if we do that, it's gonna come back, it finishes the ping, and then it runs the ls command as well. Another thing we could do that, and instead of that we could use double ampersand. And you can see here it's going to do the ping, and then it gave us our ls as well. We can also try using the pipe, and you can see it runs the ping. In this case, that doesn't actually give us the ls. So let's clear this, let's test this out on our actual web form. So if we were to put in our address here, 127.0.0.1, let's try and then put in ls afterwards, using a semicolon to separate the commands. And is that running? Submit. Oh, there we go. Okay, so it ran the ping, and then it's given us it's listed out help, index.php, and source. Let's do that again, and let's say cat index.php. Submit it. And you can see there it's given us our ping results, and now it's actually printing out, or it's attempting to print out the PHP, and it's actually created a whole new form for us there. That's interesting. Let's do that again, but let's do something else. We'll say who am I? We'll check the host name. Try that. So we can actually chain multiple commands together, as you can see there. We've got www data, and parrot is the operating system. We could do that again, but also run ifconfig. Anything else you might want to run? Let's ls the home directory, or let's ls, we'll see if we can go back another directory there. Submit that. Okay, so we printed out our ping stats, we've got our user, we've got our host name, we've got our ifconfig, and then we've listed all the files and directories from the previous directory, from the parent directory, should I say. So that's how we do command execution anyway. What about if we say 127.0.0.1 and echo you've been hacked. And if we run that, you see it's actually printed out, you've been hacked. So we could use something like this to try and gain a reverse shell. I'm not too sure if this will work for us from the same address, but let's paste in this command here to get a reverse shell and try and set it back to 127.0.0.1.1337. Let's set up a netcat listener and NLVP and on port 1337. So we're waiting for a connection, and assuming this was, obviously this is a local host, so we're getting a reverse shell from our actual host, but assuming this was a web server and we found the command execution, we would let's put in our ping, so it's actually doing the ping 0.0.0.1. So it's going to do the ping, and then hopefully it should run these commands afterwards to actually spawn a netcat connection to our local host. So if this was an actual website, we would be getting a shell to the server if this works. So let's try and submit. Let's go back to our terminal, and you can see here we've got bin sh and we have a shell. We can check who am I, and I'm www data. So you can see I've got through as www data rather than the account that we're actually on as Crystal, because this application is running as www data. So you'll see this quite a lot in capture the flags and in hacking challenges and things where you have to actually, where you'll get a reverse shell as www data, and then from here we would need to do some enumeration and try and find out if there's any privilege escalation exploits that we can run to get from www data to Crystal and ultimately to root. So I hope that's cleared up how we do the command injection. Let's see if we can go and change our difficulty. We'll change the security level to medium, submit that, and we'll go and check out this command injection now. So if we let's try and do this again. Let's try and just do ls, submit that. Okay, and it's taken a while to come back, and nothing came back. Let's just try and ping the IP address, make sure it's definitely working okay. There we go, pinged that fine. Let's try and do we'll ping the IP address and we'll do and ls, see what happens. And you can see it doesn't appear to be actually executing our command. So one thing I haven't done on the so far on the challenge or on the brute force challenge was note that you can check this help section for information about the challenge. You see here it'll describe the command injection, and it'll tell us what our aim is as well. So our objective is remotely find the user of the web service and OS as well as the machine's hostname via remote command execution, remote code execution. So we've done the low level, we have the medium. You can actually check the answers here if you get stuck. So we'll try and just come back and check between the between each difficulty anyway. So we did our low level, and we can actually see similar to what we did. We used the and command. We also use a semicolon. And then the medium level, the developer has read up on some issues with command injection and placed in various pattern matching to filter the input. However, this isn't enough. So let's check out the view source, and we can have a look at the difference between the challenges. You can actually compare the levels here, but let's let's compare the first, because we didn't actually check the first level. So let's check the first. This was the first level, so it checks what operating system we are, and it's taking the IP parameter off us, which is going to be in here, and it's checking what operating system we are, and then depending on the operating system it'll run the command. We're Unix, so it's running Linux, so it's running ping 4 times on whatever IP address we pass it, and then it gives us back the response. The difference now is that we have the only difference here, looking at the code, is that we have these substitutions, and then we have this string replace. So it's going to substitute anytime we put in and or a semicolon. It's going to substitute it with nothing. So that's why our command isn't being executed there. So let's see what happens whenever that's running in the background and we put in our it's going C4, we put in the local IP address. If we put in a semicolon and then ls, it's stripping the semicolon and it's running that. And that's why it took so long to come back and didn't return anything, same as it's doing here. And similarly, if we were to put and, it takes that out and then returns us nothing of use. So what can we do here? Well, the difference between some of these commands, this, let's say the ping command, we use the semicolon, and this essentially says run the ping command and then run the ls command straight after it. If we were to put in and here, we're saying run the ping command and then run the ls command if this ping command completed. Whereas what we can also do is just send the and command and see how this is different. You see here it did the ping and then it gave us the listed the directories. In this case, it'll just run our second command as a background job. So you can see there it's spawned it as a background job, and it's actually put the ls in between some of the ping commands here. So that's another version of syntax we can use here. There are some other things we could potentially do, but let's test that out. Let's just send it a single and submit. And you can see it's listed the directories before it's done the ping in this case, which means we can do that and say and hostname, and let's try and do and we need to spell it correctly. Hostname and who am I and ls ... see what happens. And there you can see we've run all those commands. We've got back the who am I, the hostname, the ping, and then our listing directories there as well. And similarly, we could spawn a remote shell just like we had done previously. There's no point in actually doing it, but yeah. So let's check to see their solution as well, if that matches up. That was the medium solution. Background the ping command. So that's exactly what we did there. We just used the single ampersand to background it. So let's go to the change difficulty to high, submit that, and go back to our command injection. So if we were to test out what we just ran there, presumably this is blocked as well. Let's actually open up our help. Yep, struggling to make it back. So high level. In this high level, the developer goes back to the drawing board and puts in even more patterns to match. But even this isn't enough. The developer has made a slight typo with the filters and believes a certain PHP command will save them from this mistake. So let's close that and let's take a look at the source. And we can see here we have more characters which are being blocked. We have the dash, we have the $, because we could be running something like cat ls echo ls to list the directories. So it's taken away our oops, I'm not trying to compile anything. It's taken away that, it's taken away brackets. We have the backtick. Similarly, we could use that to run commands. Oops. So that's actually taken in, if I put in here, who am I? That's actually taking the result of this command and then executing that as a command in so as you can see, it's got back the result of that. If I run who am I, it's Crystal. It's taken that and it's tried to execute that in bash. So what else do we have here? We have our pipe and the double pipe, and then the same as last time, we have our semicolon and the ampersand. So the issue here is if you notice that they've actually left a space, you can see that the description mentioned that the developer made a typo in one of the characters, and we can see that they've left a space here. So if we don't leave a space, then we should be able to say, let's ping this and don't leave a space. Let's try and just ls, see what happens, and there we go, which means we can run that. Let's do 127.0.1. In fact, what I'll do here, because I keep end up typing this out, let us go to Burp Suite just for this. Go into our history and see we've sent this off. Let's send this to the repeater, and then in here we can just go and say who am I. Still takes a little while to come back, and where's the result? www data, and then we could say hostname and ls. We submit that, and again we can check here for the result. We could also, if we wanted to, we could say we want to open this in the browser, so we can request in browser, we can show response in browser. Say in future, just copy it, don't show this dialog, so we just copy that, paste that in there, and that'll actually go, and I mean that's probably not really a quicker way of doing things anyway, but a few different ways you can do that. But so that's our method for bypassing that. Let's go to view help again and see what they have for the solution. This isn't enough. The developer has made a slight typo and believes a certain command will save him from mistake. Okay. Trim. Let me see. Removes all leading. Let me see what they. View source. So the trim's only going to trim the space at the end of that as well. So if we have our command in as this, it would remove this space. And then the final difficulty would be impossible. I'm not going to change it to impossible because we'll just try to run this command and then it's not going to work, and it's just going to take ages to respond because it's where's the source code here? Because it'll fail to run a command, so it'll take a long time to respond. So if we go back, compare all levels, and let's just have a look at the impossible anyway, and you can see that there's a lot more validation being done here. Okay, interesting, I can't put that on full screen. There's a lot more validation being done here. We're actually making sure that we're dealing with an IP address that's in 4, it's just, and that they're all numbers. It's just 4 numbers separated by dots, and it won't accept anything but that. So actually, let's go and change the security, because I think it might give us some kind of message. So change this to impossible. Let's go back to command injection, and let's put in the last one that we tried. Submit that, and yeah, you have to enter a valid oh, you have entered an invalid IP. Yeah. Okay. I hope you've enjoyed this video. In the next video, we'll be looking at the CSRF or CSRF vulnerability.